So looking at the board now, you can see the various aspects. I will try to zoom a little bit so that you can actually see what we're referring to. General method is there. First principal method, chain rule, product rule, then we'll have the quotient rule, then we'll also have the implicit differentiation. However, what we'll do is that there are other differentiation concepts will be bringing to your notice, but they still fall within the range that we've already stated above. Something like for today, we are going to begin by looking at the general method of differentiation. Please, you need to pay attention. There are skills involved in this. Just look at the formula and the principle, because every mathematical concept is guided by a principle and a law. So the principle and the law will be our guiding post. Alright, so let's take examples. This is a formula, but there are many of them I've already mentioned, about 6 or 7 or 8 of them. We're picking them one after the other. General method of differentiation. Remember that we're talking about trying to find the change in the variables with respect to what now? Another variable. All this has to do with the graphical concept. It's the concept of graph that we are looking at from this dimension. Alright. Now number one, if y, are you there? If y is equal to x, find y with respect to what? X. Find the value of y with respect to s, or differentiate y with respect to s. What are we going to do? This is the law. Differentiating y, changing y over change in x will be equal to x. Of course, the power here is 1. The power of x is 1. Of course, you know it's 1, not written. Multiply this coefficient, this letter, by the power, and then take away 1 from the power. That's the rule. Listen, multiply the coefficient by the power, and then take away 1 from the power. See what I mean? We'll now be having, with this we'll have 1 multiplied by the variable, then take away 1 from the power. You'll be having x to the power of 0, which is what? 1. And this has obeyed the law we gave initially. We said initially that the coefficient, the differential coefficient of any given variable is unity. So we arrive at 1. So multiply the power by the given expression, then take away 1 from that given expression, and how it will happen next. Now number 2, let's look at this. If the f of x is equal to x squared, what are we going to have? What we have in this case, first of all, what do? We multiply this x with the variable by the power and take away 1 from the power. So we're having this. Changing y over changing x, right, will be giving us 2 multiplied by x, 2 minus 1. That's the law. That's the law that guides this. So this will give us 2x to the power of 1, which is equal to what? 2x. So differentiating y in terms of x squared, you'll be having what? 2x as your answer. Let's take one more example. For example, let's say that we have y, that's number 3, y is equal to, let's say, 3x. Differentiate y in terms of x, so dy dx will be equal to, now the power of the variable is 1. So you have 1 multiplied by 3 multiplied by the x, 1 minus 1. Right? The 1 here, multiply this, multiply by the variable, then take away 1 from what now? From the variable we are dealing with here, it is x. Don't forget that we're not talking about the letter. Our concern is we're differentiating y in terms of x. But here x is having 3 as it was coefficient. We are dealing with variable. Change in one variable with respect to change in another variable. So in this case, we'll be having 3x, 1 minus 1 is 0. And of course, by the law of indices, any number or any alphabet or any variable to the power of 0 is 1. So we'll be having 3 times 1 is equal to 1. So the answer here is 3. Let's take one more, number 4. Y is equal to, let's say, 2x squared plus 4. So with this is a constant. And by the law we said that for any constant, the what now? The differential coefficient should be what? 0. When I differentiate this, normally you differentiate each term. This first term, this second term. Let's differentiate the first term and then we'll differentiate the second term. So here we're having dy, the x changing y with respect to x, dependent, independent. So we're having 2 multiply 2, then multiply the x. Then we'll have 2 minus 1. This is for this. Coming to this one now, we have 0 already. Because we said for every constant, the differentiation of a constant is 0. Please, you need to bear that in mind. Right. So we have this now. So what do we do next? 2 times 2 is 4. Then we'll have this. We'll be having 4x. 2 minus 1 is 1. It's power 1. It's equal to 4x. That's the final answer for this. Alright. So I hope you have learned something. We're going to still go further to look at more possibly semi-complex examples before we now go into the next item. I hope you have learned. Any question you have, please put in the comment section. You can equally send a text or meet us on WhatsApp. We'll be able to attend to any matter with that regard. Thank you very much.